Hello friends, welcome to Head or Tail Education. Today our topic is types of matrices in maths. Now first we understand what is the matrix and what is the definition of matrix. A simple definition is the arrangement of numbers in row and column is called matrix. So for example, if we have matrix M, so may be possible the number of rows m1 m2 m3 so on, okay, and number of columns m1 m2 m3 so on. So this is the simple matrix is M. The example of matrix like matrix A, so here is the 3 row and 3 columns, so 3 by 3 matrix. The other example is matrix B. Here is the 3 row and 2 columns. So this is the size of matrix. Actually the size of matrix is 3 by 2 or 3 by 3. So size or order of matrix is the count the number of rows and columns in matrix. Now matrix representation is like the square brackets and round brackets. Now order of matrix and matrix element. So in general way the matrix is represent equal to matrix equal to square brackets m of ij and size of matrix like 3 by 3. So matrix M is 3 by 3. Now next example is matrix A equals to square bracket A of ij and 3 by 3. So matrix A is also 3 by 3 order. Now other example is matrix B. So size of matrix is 3 by 2. Now what is the matrix element and how we can get matrix element by the matrix index, row column index. So matrix element is find by row and column index. Suppose this matrix M1 M, so M21 means second row and first column. This is the element. Now M32 means third row and second column. Now example like this, the example of matrix A. So here is the A of 32 means third row and second column. This is the value is 5. Now next is A is 21, so equals to value is the second row and first column. So this representation is indication of the matrix value. Next our main topic is type of matrices. So in order to the first types of matrix is square matrix. So if number of rows and columns are equal is called square matrix. So like this, for example, here is the 3 column and 3 row. For example matrix A. So matrix A is 3 column and 3 row. So size of matrix is 3 by 3. Now the elements M11, M22 and M33, M11, M22 and M33 of above matrix is called diagonal elements. So this is called diagonal elements. So matrix A of diagonal element is 2, 3 and 2. Now sum of diagonal elements M11, M22 and M33 of above matrix M is called trace of matrix. So sum of diagonal element is called trace of matrix. So we write like this: trace of M means matrix name, or like small tr matrix name. Then M1 m1 plus m22 plus m33, all sum of diagonal elements. For example, matrix A, so TRA equals to 2 plus 3 plus 2, which is equal to 7. So this is the first type of matrix. Next is second type of matrix. Second type of matrix is rectangular matrix. If number of rows and columns are not equal, is called rectangular matrix. So we have seen in our example, this matrix M has 2 rows and 3 columns. So size of 2 rows and 3 columns is 3 by 2. Now other matrix example is A. So here is the 3 rows and 2 columns. So this type of matrix is called rectangular matrix. Next is diagonal matrix. So main diagonal matrix elements are not equals to 0 and others elements are 0 is called diagonal matrix. Means the diagonal elements is not equal to 0, first condition of this, and other elements of matrix is 0, so is called diagonal matrix, represented by DIAG, diagonal, and then diagonal elements A11, A22 and A33, and where and A of ij is not equals to 0. So this A of ij is not equal to 0, and when I is not equal to j, when I is not equal to j, so row and column index is not equal to, okay, so this is called diagonal matrix. Now fourth number types of matrix is scalar matrix. So when all diagonal elements are equal of diagonal matrix is called scalar matrix. Okay, so here we in example we say we saw the k, this is the diagonal elements and all are equals. In other example matrix B, the 2 2 2, this is also diagonal element and all are equals. So this is called scalar matrix. So represent by A equals to A of ij, where A of ij equals to k, okay, when I equals to j, and 0 value position 0 when I is not equals to j. So this is the scalar matrix. Now fifth number matrix is unit or identity matrix. In this matrix the diagonal elements of diagonal matrix are equals to 1, okay, and other elements are 0 is called unit or identity matrix. Like this diagonal element is 1 1 1, so this is the unit or identity matrix, represented by A equals to A of ij, where A of ij equals to 1 when I equals to j, okay, and 0 when I is not equals to j. Now sixth number matrix is symmetric matrix. So what is the definition of symmetric matrix? A square matrix is called symmetric matrix if elements of A of ij equals to j of I. Means that this position A of ij elements equals to j of I. So here in this example we have seen the A of 1 2 or A of 2 1 equals to h, this element, okay. Next A of 1 3 equals to A of 3 1 equals to g, so this element and this element. Now A of 2 3 equals to A of 3 2 equals to f, so this is element. So this type of matrix is called symmetric matrix. So seventh number matrix is skew symmetric matrix. A square matrix is called skew symmetric matrix if the elements of A of ij is equal to minus A of ji. The matrix is all diagonal elements value is 0. This is important. Okay, so A equals to, this is the example of matrix. So A12 equals to minus A21 means the A12 is H and A21 is minus H. Okay, now next A13 equals to minus A31, so G equals to minus G. Now A23 equals to minus 32, so F equal to minus F. Now eighth number matrix is 0 or null matrix. Any m into n order matrix of each element is 0 is called 0 or null matrix, represented by 0 or their size m into n. Now example is the matrix A equals to all elements are 0, so size is 0 3 by 3. Now other example is B equals to all matrix element is 0 but the size is 3 by 2. Okay, this is called 0 or null matrix. Now ninth number is row matrix. In row matrix only one row is available is called row matrix. So example A equals to like 0 H G etc. So this is one row matrix, size is 1 by 3 means one row 3 columns. Now number of 10th of matrix is column matrix. Only one column is available in matrix is called column matrix. So example is this, the matrix A equals to 0 H minus G, like this is one column only and the row is 3, so A equals to 3 by 1. Now 11th number matrix is submatrix. So remove any number of rows and columns from given matrix. After that final matrix is called submatrix. Okay, so for example the matrix A has 3 row and 4 column. So I remove here like this first row and last column. So remaining matrix is 2 7 9 3 4 6. So this matrix is submatrix of matrix A. Okay, so you can remove like middle also, like 3 7 4 or maybe the bottom of this. So remaining element is others for you, for matrix B different. Okay, now this next is number of 12 is principal submatrix. Okay, so definition is remove same number of row and column from given square matrix. After that final matrix is called principal submatrix. So this here in principal submatrix is important part is you need to square matrix. After that you can remove the same number of row and column, like here this time we remove the second column, so now the row is also second number of row. So after that element new matrix is B, so element is this, so this is called 3 by 3 matrix B. This is the principal submatrix example. Next 13 number is leading submatrix. So definition is remove any number of last rows and equal last columns from given square matrix. After that final matrix is called leading submatrix. So important is last rows and last columns from square matrix. So here is the we remove the last column from last side, 2 columns remove, and last row from last side, bottom side, 2 rows remove. So final matrix is the B, 1 2 3 4. This is called leading sub matrix of A. Now 14th number matrix is periodic matrix. Periodic matrix means like this is the matrix A, is simple matrix. Now if K is positive number, if any value K is positive number, okay, then matrix A, this is called matrix periodic matrix if the power of A is K plus 1, then equals to the result is A. Here if K is smallest to smallest positive number, okay, then A, the power of K plus 1 equals to A, means K is very small number, then we use this equation A power of K plus 1 equals to A, then K is called periodic interval of matrix A. So this K is called periodic interval of matrix A. Now because, so this example, if power of A is equal to 3, so equals to result is come A. Now we can write like this, power of A equal to 2 plus 1 equals to result again A. So the periodic interval is 2. So here is the 2, the periodic interval. So this is the periodic matrix definition. So 15th number matrix type is triangular matrix. A square matrix is called triangular matrix if each element of upper side from leading diagonal like this, or lower side from leading diagonal this, so is 0. So if here is the example upper triangular matrix, so this is the diagonal and below the diagonal all elements are 0. This is called upper triangular matrix. Here is the lower triangular matrix. So upper side all elements are 0 and below the diagonal all elements is non-zero. This is the lower triangular matrix. Now next type of matrix is number of 16 nilpotent matrix. So what is the nilpotent matrix? If the matrix power A of K equals to 0 is called nilpotent matrix, where K is positive number, means this is the example of matrix A equals to 1 minus 3 minus 4 minus 1 3 4 1 3 minus 4. Okay, so if we square of A matrix, means A is multiplied by A, then output is 0. So this is called nilpotent matrix. Okay, and nilpotent matrix, the power of nilpotent matrix is 2 here. Now the 17 number matrix is equal matrices. Okay, so if we have two matrices like A and B, then order of both matrix is same, so 2 by 3 and 2 by 3, and their correspondence elements are identical, means so A11 equals to 1, A12 equals to 2, A13 equals to 4. Okay, A21 equals to 0, A22 equals to 5, and A23 equals to 3. So this type of matrix is called equal matrix. The element values are different, but on the positions each element is available. Okay, like A11 equals to 1, so both matrix, both same position elements are available. So this type of matrix is called equal matrices. Next 18th number matrix is idempotent matrix. It's very simple. If any matrix A, the power of matrix is 2 equals to again matrix equal to A is called idempotent matrix. Means the example of this matrix A equals to this 2 minus 2 minus 4 minus 1 3 4 and 1 minus 2 minus 3. So if we do the square of matrix, means A of power 2 equal to A is multiplied by A, so resultant matrix is A. So this type of matrix is called idempotent matrix. Okay. Now 19th number matrix is involutory matrix. This is also property is if the power of A equals to 2 means square, then the resultant matrix is output is I means unit matrix is called involutory matrix. For example, the matrix A equals to 1 0 and 0 minus 1. After, so this is the 2 by 2 matrix. Now we square this matrix, so A square equal to A into A equals to I. So output, the resultant matrix is again unit matrix. So this type of matrix is called involutory matrix. Now tell summary. Finally, we learned intro about matrix and their element and order. Okay. Then types of matrices. How many types of matrices are available? So in the sequence, the types of matrices is first is square matrix, then rectangular matrix, then diagonal matrix, then scalar matrix, then unit matrix, then symmetric matrix, then skew symmetric matrix, then zero or null matrix, then row matrix, then column matrix, then submatrix, then principal submatrix, then leading submatrix, then periodic matrix, then triangular matrix, then idempotent matrix, then nilpotent matrix, then equal matrix, and finally involutory matrix. Hope tutorial will help to learn about types of matrix. Thanks to watch Head or Tail Education.